Hello, I hope that all is well during this time. My concrete building is the Diego Portales Economic School in Santiago, Chile. The building was designed by Rafael Havea and construction was completed by 2013 by a local construction company called Bravo Izquierdo. Concrete was specifically chosen to oppose the glass buildings commonly found in the area. Concrete is also chosen due to the ability of prefabricating certain structures of the building, which saved on time and money. Lastly, concrete is also chosen due to its strength and fire-resistant properties. I chose the structure due to its unique focus on building environment, with the vines growing on the west facade, to the wall openings to enable control sunlight, to having the west facade gain the cool westerly winds in the summer months. This building has considered many environmental details to reduce occupational usage. I assumed the following beam column setup by looking at common industry practice. I designated different ultimate load combinations based on different area usage, such as classrooms and hallways. By assuming a similar floor layout in the floors below, as well as the slabs being two-way slabs because of the low breadth to length ratio, I determined the loading on the beams. By following Eurocode 2, I also determined the wind loading on the four facades. Due to the presence of two staircases running through the entire structure, I assumed that wind loading would be transferred to those structural cores rather than to the beams and columns. By following Eurocode specifications, I was able to design the following concrete beam with the following dimensions. During shear resistance calculations, I discovered that I only required nominal shear lengths. Here are the dimensions for those shear lengths. Due to the presence of a core in my building, I assumed that lateral forces are transferred to the core rather than the columns. I proceeded to calculate the axial loading as well as the bending moment in the columns. Using the design charts, I was able to determine the value for the area of steel to be 720 millimeters squared, hence meaning 4 H16 bars could be used. I also determined that the column was below the slender limit, hence meaning that it was not a slender column. By looking at the cradle to gate embodied carbon dioxide per ton chart, I was able to determine that assuming 1% steel reinforcement for reinforced concrete, for every 1 ton of reinforced concrete produced, 156 kilo carbon dioxide per ton is produced, where 40% of it is from steel alone. Therefore, meaning steel has an important part to play in reducing carbon emissions. Use of glass fiber reinforced polymer or even bamboo has been explored in the past and has proved to be able to substitute steel in specific scenarios. So therefore, alternative to steel should be looked at.